so get out your note cards because you're going to want to add these last two trig things to your note cards. Okay, ready? Sine. The abbreviation for sine is S-I-N. It looks, sine is spelled S-I-N-E. Okay, so what we're saying is sine, not sin. Okay, we're not sinning in math. We're doing the sine in math. Because we're doing tangent and cosine, and so we abbreviate all of them to just 3 letters. All right, so the sine of A is opposite side of the angle. If angle A is what I'm looking at, it's the opposite side to angle A, always to the hypotenuse. So if this is angle A, the ratio of sides for angle A would be what? 8 over 17, right? Cosine is adjacent side to angle A over the hypotenuse. Adjacent side to hypotenuse. So, what would that ratio of sides be for this example? 15 17s, right. Once you figure out tangent and you get that right, it makes it, sine and cosine just fall into place nicely. All right, what about B? If B is angle that I'm comparing, how would I write the sine of angle B? 15 17ths. So the sine of B is the same thing as the cosine of A. We only got 3 sides, so somehow we have to do some repeating, correct? All right, what is the cosine of B? 8 over 17. And so that's the same thing as the sine of A. For argument's sake, what would you say that the tangent of A is? 8 over 15. What is the tangent of B? Yep, 15/8. So they're reciprocal functions. Okay? All right, so there's a little saying, because what makes this hard is which one is opposite over adjacent, or opposite over hypotenuse, or adjacent over hypotenuse. I'm all confused. I can't remember. So there's a little saying. Okay, it sounds like so ka toa. Sounds like an Indian word. Soka-toa. Okay? Sine. What is the sine? Opposite over hypotenuse. What is the C going to stand for? Cosine. What is cosine? Adjacent over hypotenuse. T is going to represent the, what is the tangent? So everybody say Soka-toa. There you go. Soka-toa, Soka-toa. All right? Soka-toa. What? Me doing this or the Soka-toa? Walk up a wall? It's undefined. Gotcha. Okay. All right. So I'm glad you will always remember this. When you think of Soka-toa, you will think of Mrs. Dunn. Okay? Soka-toa. All right. Here we go. I want to find x and y, and you're going to have to decide now. So the easiest thing to do is I'll go Soka-toa. If you want to, I mean, you definitely need to put these sine and cosine in your flashcards, please, with a triangle for each of those, okay? It probably is helpful for you to put Soka-toa in there, too, just so that you kind of remember what that means. You don't have to, but it's nice to have that. Okay? All right. So let's say I want to, on this exercise, do x first. Here's my x. Obviously, I'm going to have a right triangle, so I can use my trig function. I'm given 73 degrees. Who can raise your hand and tell me how am I going to set up my ratio to be able to find x? What do you think? Aaron? Okay, so the cosine, tell me what to write. Uh-huh. Good. All right, who can show me mathematically, how am I going to rearrange this so that I solve for x? What's my next step going to say? Kaylee. Right, if it's down here in the denominator, multiply both sides by x, gives me x cosine of 73 equals 6. Who can tell me how I finish this problem up? Isabel? X is equal to 6 divided by the cosine of 73. And when we plug that into our calculator, let's round to the nearest 10th. 20.5. Okay. Okay. Who can set me up for y? Who can set me up for y? Mary. Okay. Oh, so you want me to do sine of 73? Is that what you want me to do? So the sine of 73, what are you going to tell me to do? Okay. Now the only drawback to doing it this way, and she's got it right, what would be the drawback to doing it this way? What do you think, Athena? Then it's going to lead to an error in part 2, right? You can do it, absolutely. If I wanted to make sure that I got this right, how else could I find y? How else? Gabby? Right. Either way will give you the same answer. Just be aware. Sometimes you have no choice but to use information that you gained earlier in the problem. But it's always better to try and see, is there another way that doesn't use a value that I've had to generate in case I plugged it into my calculator wrong? Okay, so that there would be a carryover. Emma? Mm-hmm. Yeah. Probably not. I'll probably say solve. Mm-hmm. 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 They should not be. If you, yeah, you should. If you plug in 20.5 sine of 73, that should be the same thing as 6 tangent of 73. Oh, because we rounded x. There you go. Exactly. So approximately, what are you going to get? Are we all good with that? Exactly. All right. Here we go. You do that one yourself. Figure out x and y in whichever way you want. Decide if you want to find x first or y first. I don't care. Oh, no. Here, this is an S. Mm-hmm. Yeah, we'll just kind of keep it. Unless we say otherwise, we'll just do it to the nearest 10. Unless I say exact. All right, Hannah, tell me, which one did you find first? Tell me how you decided to find y. And so 6 tangent of 28 equals y, which left me with y to be what? Are we all good with that? Okay. All right. Sophia, what did you do for x? Okay, cosine of 28 equals 6 over x. So x will equal 6 over the cosine of, which is what? 6.8. Okay? So you might have gone a different route. Did you all get that same answer? You should have. Here's something that I want you to see. If this is 28 degrees, what's this? 62. Why do we know that that's 62? Because it has to equal 180. All right. So if I said the sine of 62 is equal to 6 over x, that means x would equal 6 divided by the sine of 62. Wouldn't you agree? And what would that give us? Isn't that the same thing as 6.8? Remember, the cosine of one angle is the same thing as the sine of the other. So if I don't want to use 28, I can use the 62. But which angle can I never use? The 90. Okay? Yes? Remember, the adjacent side is never the hypotenuse. Right? So here's 28. Where's my adjacent side? Yep. Oh, did we clear you up? Perfect. Okay. All right. So here we go. Angle of depression. When you are depressed, are you happy or sad? So you're going to look down. Here's your eyeball. And you cannot make fun of my drawing. If you are depressed, there is your angle of depression. It is you looking straight and you looking down. That angle that you create looking down to the horizontal if you were looking straight out. Does that make sense? Okay. All right, angle of elevation. If you are elevated, are you happy? If you are elevated and you are happy, you will look up. So here's my eyeball. Here's my horizontal look, correct? So if I'm going to do an elevation, I am going to now look up. There is my angle of elevation. Be very careful that you don't get them confused. Okay? Huh? Yes. If it helps you, that would help. Okay? Good. Okay? All right. So, a pilot is looking at an airport from the plane. Where is he probably if he's in the plane? Up in the sky. All right. Again, no making fun of Mrs. Dunn's drawings. Okay? And he is looking at his little airport. There's my airport. Okay? So here is his angle of sight. Wouldn't you agree? That's his angle of sight. His angle of sight is what you do when you always look straight out. Okay? No, this is the problem. Yeah, I would put angle of depression and elevation in your note cards. Okay? If the angle of depression is 29 degrees, if the plane is an altitude of 10,000 feet, how far is the plane from the airport? Okay. So we're going to use some geometry here. Where is his angle of depression? Isn't it between these dotted lines? So we're going to say this is 29 degrees. Notice I have a right angle here. Wouldn't you agree? Created a right triangle, right? How tall, how far up am I? Right? I could. Well, I would use the other side. Okay, but so that means this is 10,000, right? How far is the plane from the airport? That's kind of confusing in this problem because I really wasn't clear as to where how far is. But probably what I'm looking for is what? No, I'm probably looking for this. Like if I'm here, how far am I from the airport? Versus how far do I have to fly to get to it? I'll make that a lot clearer on the word problems, and they'll be clearer in the book, okay? But let's say that this is what I'm looking for. So here's my right angle. If this is x, where else is x? Up at the top. Out of curiosity, what kind of lines are these? Oh, this is called the what? Oh. If this is 29, if that's 29, where else is 29? Yeah. What kind of angles are those? Oh. Okay. Okay, if this is what I want, I will use tangent. Tangent of 29 is equal to 10,000 over x, y, whatever you want to let. So that means x is equal to 10,000 over tangent of 29. 1804 feet. Try it again. Athena. Because we said that these are horizontal, or these are parallel, right? And we're creating basically a rectangle. So if this is x and this is x, and really doesn't matter then, as long as you're placing the information in the right spot. We have two triangles that are identical. So which triangle do you want to use? It really just is up to you. Absolutely. That's why if this is x, then this is x up here. Okay? Any other question? There was another hand over here. You know who uses a lot of this stuff is civil engineering. When they are looking at roads and trying to decide the incline that they want to make this or build this road at, they use a lot of geometry and a lot of trigonometry. So this is the very simplistic problem, okay? You'll do a lot more trig next year when you get to pre-calc. I love trig. It's just fun. Mr. Kogan. Mr. Kogan. Yeah, pre-calc and trig generally are, I don't know, next year probably, because I think last year we had 2 classes, and so there was enough to create a trig class out of that. This year that won't be that option because there's only one of you. Most of you will go on. If you're someone who is wanting to slow down, then you would take the pre-calc 11th grade So you'd be in 11th grade pre-calc, which is a different book. It's not so difficult. But then you'd bump right back up. You could be into some kind of calculus then your junior year. Yeah. But the problem then is that you will have not had that geometry, and you have to have it. And so when you're in with the juniors, what we do then is those last 2 weeks when they go on do apostolic or whatever, you would stay and do the last few chapters of your geometry. Okay. All right, here we go. You are at the bottom of a hill. Here's my hill. All right. The whole idea is always to draw and form a right triangle. Okay? The angle of elevation, so from my line of sight, is 21 degrees to the top of the hill. So here's my angle of elevation, correct? It's me looking up. I'm creating it at the bottom of my man instead of like my eyeball, but it's the same thing. Okay? So here's my angle of elevation. It's 21 degrees. The hill has an altitude of 1,200 feet. Where does that go? That's why we need to know what altitude means. It's the height, right? And the altitude will always form a? That's why we have a right triangle. Okay? How far will you walk to get to the top of the hill? Now, this one's easy. What am I looking for if I'm going to walk? Because I cannot walk to the middle of the hill in the middle and then up the hill, because we can't walk straight up, right? So if I am walking to the top of the hill, then I am walking all right. So maybe my hill should have been more like this, with me down here. So my line of sight still is doing the same thing. But you guys got the idea, right? Yeah. Oh, you can fly there. Okay. So how do I figure this out? What would I do? Emma? Yes. So that means x will equal 1,200 divided by? Yep. And so what does that give me for x? Okay. One person tell me. Okay, Sydney. Okay. All right. How are we doing? We like this section? Good.